Okay, so we're going to be going over division properties of exponents. If you remember in the previous section, we learned like x times a times x times b is equal to x to the a plus b. That is to say that when multiplying, you need to add the exponents. So then it follows that when you're dividing, you're going to subtract the exponents, right? So this leads to some of these rules right here. Let me go ahead and go over the first one. The first one is going to be the quotient rule for exponents. Quotient rule for exponents basically states that if you have x to the a divided by x to the b, it's going to look like this. X to the a divided by, I don't like that a, let's try that again. X to the a divided by x to the b. What we just said right now is when you're dividing, you're going to go ahead and subtract the exponents. This is going to be x to the a minus b. So that's the first rule that we're going to be going over. The quotient rule for exponents. The next one is going to be the negative exponent rule for exponents. This one says that if you have x to the negative a, you notice how I have a negative exponent. When we're doing problems like this, we don't like negative exponents. And so we're going to switch that negative exponent to its equivalent, which would be 1 over x to the a. It's the exact same thing. It's just you're going to move that thing to a different spot. So right now, x to the negative a is actually on the top of a fraction because remember it's over 1. And to get rid of the negative, you bring it down to the bottom. If you have a negative exponent on the bottom, then you would move it. So you would push it up to the top, okay? The zero exponent rule basically states that if you have x to the 0 power, then the answer is going to be 1 as long as x is not equal to 0. So just pretty much basically anything to the 0 power is 1, except for 0 to the 0, that one actually gives you an error. And then the last one we're going to be talking about is the quotient to a power rule. And that one says if you have x over y, if you're dividing something and you raise it to the a power, then again, it's almost like that rule that we had before. We're pretty much kind of sort of going to be not distributing that a, but it's going to look like x to the a over x to the b. You're just going to take that a and everything inside that parentheses gets that exponent. Okay, so on these next couple of problems, we're going to go ahead and show you how some of these things work. This is going to finish out the rest of the page, so go ahead and press pause in the video right now. Copy these problems down. I'm going to assume you already did that, and we're going to go ahead and get started. So let's talk about the first one, x to the fifth over x to the third. I'm going to do this the long way, just 3 times, okay? And after that, I'm just going to be using the shortcuts, all right? So, by the way, these are all shortcuts. I mean, they're properties, but they allow us to do these problems a little bit quicker. And what I mean by that is if I were to do it the long way, then I would just write this out, right? Like x to the fifth means x times x times x times x times x. And x to the third means x times x times x. And if I were to do these, well, then these would cancel each other out because it makes 1. These would cancel each other out. These would cancel each other out. And what you would be left with is an x times x, which we know is x squared. Okay, so that's the long way of doing it. And I'm saying the long way because you have to write them all out, okay? Or we're going to do it a different way. We're going to use it with the shortcut. The shortcut is right here. It's saying if I have something that's being divided like that, I can go ahead and subtract the exponents. I'm going to write it out x to the fifth over x to the third. Let me go ahead and jot that problem down again. X to the fifth over x to the third means that I'm going to be subtracting those two. So that's going to be x to the 5 minus 3. Notice that I'm doing the top number minus the bottom number, okay? X to the 5 minus 3, that's going to be x squared. And we get the exact same answer both ways, okay? So, all you have to do is subtract, and that basically takes care of this shortcut on the top. If you have two things being divided with the same base, you can just go ahead and subtract those exponents. All right, let's take a look at the next one. That says x to the third over x to the fifth. It's very similar. I'm going to do it the long way just so you can kind of see where this rule is coming from. X to the third divided by x to the fifth, that's going to be an x times x times x on the top. And then on the bottom, that's going to be an x times x times x times x times x. And if I were to cancel these out, these would cancel, these would cancel, these would cancel, and I'd be left with an x times x, but it would be on the bottom of the fraction. So I'm going to get an x squared on the bottom. There's nothing really on top except for, you notice that I'm writing these as ones because x divided by x is 1. So you have a 1 times 1 times 1, which means you still got a 1 over on the top. It becomes 1 over x squared. Okay. So I know that's what the answer is supposed to be, but how is this going to work using the shortcut? I'm going to write that problem again. The shortcut says that all I have to do, because they have the same base and because I'm dividing them, all I have to do is I have to subtract those exponents. Remember, it's the top one minus the bottom one. So this is going to be x to the 3 minus 5, which 3 minus 5 is negative 2. Now remember what I said earlier, we do not like negative exponents. If the problem is not done, we don't use negative exponents. So what we're going to do is we're going to move it. And I said that this is technically x to the negative 2 over 1. To get rid of a negative exponent, you just move that thing to the other side. So right now, because it's on the top, I'm going to move it to the bottom. But in doing so, I get rid of the negative exponent. So now I get the x squared on the bottom, and you leave it with a 1 on top. Okay, and again, as you notice, the answer is going to be exactly the same. All right, and then the last one is x to the 5th divided by x to the 5th. I'm going to go ahead and write it the long way. That technically means x times x times x times x times x over x times x times x times x times x. And if I start canceling all these things, I get a 1, I get a 1, they cancel, cancel. I'm getting all these ones, which really becomes 1 times 1 times 1 times 1, which is just 1. And so that's the way it works doing it the long way. If I wanted to shortcut this x to the 5th divided by x to the 5th, because it's a division, I get to subtract the exponents. That becomes x to the 5 minus 5, which is x to the 0. And according to the shortcut, anything to the 0 power, as long as that x is not equal to 0, anything to the 0 power, the answer is going to be 1. So, we get to see both ways of doing it. So we've seen this one, we've seen the first one in action, the second one in action, and the third shortcut in action. We still haven't seen this, but I think this one's pretty okay. Again, anything inside the parentheses gets that power of a. All right. Let's move over to the next ones. Let's see how we're going to handle these. From now on, I'm not going to write them out the long way. I'm just going to go ahead and use the shortcut. Remember that I'm dividing, which means I'm subtracting exponents. When you divide, you subtract exponents. So you can only divide ones that have the same base. So the 3 and the 5, I'm going to go ahead and match them up. That's going to be x to the 3 minus 5. And then 7 and 4, I'm going to do that as well. Y to the 7 minus 4. 3 minus 5, that gives me a negative 2. So x to the negative second power. And then 7 minus 4, that gives me a positive 3. Now, I would say that this is done, except it's not, because again, we do not like negative exponents. Right now, this technically means x to the negative second, y cubed over 1. So what I'm going to do is, because I have that negative exponent, I'm going to move this one over to the bottom. But when I do that, the negative exponent goes away. So instead of a negative, now it becomes a positive. The y cubed is still going to stay on the top, but the x to the negative 2 is going to move to the bottom, and in doing so, it becomes a positive. So this should be my final answer. I'm going to go ahead and highlight that negative exponent, and then just kind of put an arrow here just so we know, like, hey, negative exponent's not okay, got to move them, okay? All right, let's move on to the next one. On this next one, it looks like I have a power to a power. Remember, just like on the previous one, everything in here is going to get that power of 5. But when you have a power to a power, you need to multiply. That was from the previous section, the notes that we had there. So I have this 3 to the 5th, which means I need to multiply these two. And then I have this 2 to the 5th, which means I need to multiply those two. So this is going to be x to the 3 times 5 over y to the 2 times 5, because I have a power to a power. When you have that, you multiply exponents. That means this is going to be x to the 15th. Let me go ahead and erase that since I was using big block things here. X to the 15th over y to the 10th. And we are done with that one. All right, I'm going to go ahead and join up all the ones that are similar. So again, I'm dividing, which means I am subtracting exponents. This is going to be x to the 8 minus 2, y to the 3 minus 3, z to the 2 minus 10. Always the top number minus the bottom number. 8 minus 2 is 6, so this is going to be x to the 6. 3 minus, that's a minus, guys. 3 minus 3 is 0, so that's a y to the 0. And then 2 minus 10 is negative 8, so z to the negative 8. A couple of things on this one. Remember that when you have a zero power, that becomes one, which means if I'm multiplying by one, it basically goes away. You could have also noticed that these going to cancel, and so again, it's going to go away. Okay, so this y to the zero, it's going to disappear because it just becomes a one. When you multiply anything by one, it goes away. I do notice that I have this negative exponent power here, which means this thing is going to go to the bottom. So on the top, what do I have? I have an x to the 6. The y to the 0 goes away. And then that z to the negative 8, I'm going to push it to the bottom of my fraction. And when I do that, it becomes a positive exponent. So it's going to be over z to the 8th. And that is my final answer. All right, we got three more problems, and I think like a little bonus problem just so you can kind of take a look at it. It's one of the easiest hard questions that we have. On this problem, let me go ahead and do what I think most students tend to do first, which is they see this exponent on the bottom and or on the outside of that parentheses, and they say, "All right, I know what I got to do with that four. That four goes everywhere. It goes everywhere, guys. So it's got to go here, 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 and here. Every single one gets a power of 4. Now remember that when you go 3 to the 4th, right, you technically multiply those exponents together. So what am I going to end up with? I'm going to end up with an x to the 3 times 4, y to the 5 times 4. Let me go ahead and highlight this and just say this goes here, 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 and here. X to the 9 times 4. And then y to the, you remember that has an imaginary 1 there. So this is going to be 1 times 4. All right, when I do that, and let's go ahead and multiply these. This becomes x to the 12th, y to the 20th, over x to the 36th, y to the 4th. I think you should start getting the hang of this. So I'm not actually going to write the subtraction. I am going to write what it is, though. So 12 minus 36. When you do that, you get a negative 24. Now the mistake is going to be for you to put that x to the negative 24 on the bottom. When we subtract, we automatically push it up, and we figure out what happens with it later. Okay. What I mean by that is, I don't care that this is a negative right now. I'm still writing it up on top of my fraction. And same thing here, 20 minus 4 is positive 16. Notice how both of them, I'm just subtracting and I'm writing them down and seeing what I'm getting. But now is when I realize, like, oh, wait a minute, this is a negative exponent. We don't like negative exponents. Now I'm going to push that guy to the bottom. Okay, so don't do it like a double push, which is a mistake that I see students do. Okay, so the positive exponent stays on top. The negative exponent, we're going to push to the other side. And we're going to, when we do that, the negative exponent is gone. That's the whole reason why we're moving it, is so that I don't have a negative exponent. And I believe that's as far as we can go with this problem. Now, in this next problem, I want you to notice what we did here. We wrote the exact same one, right? That's not a mistake because, like I said, most students are going to take that 4 and distribute. It's not distributed property, but kind of feels like it, right? That's not the way I would tackle this problem. The way I would tackle this problem is I would simplify everything inside the parentheses first and then deal with the 4. So we're going to show you both ways, and then you can tell me what you feel more comfortable with. But I would take care of the stuff inside the parentheses first. That means I'm going to go ahead and subtract those. 3 minus 9, that's going to give me a negative 6. And then 5 minus 1, that's going to give me a positive 4. Again, please realize that when I did this, I didn't care that it was negative. I pushed it to the top. I didn't care that it was positive. I pushed it to the top. Now that I have this, now I'm going to go ahead and worry about this negative exponent, which means I'm going to go ahead and move that one to the bottom. That negative exponent is going to go to the bottom. Let me go ahead and write it down here. That means I still have a y to the fourth on the top. And then I have an x to the positive 6 on the bottom. But I still have not done this exponent of 4 just yet. So that's still hanging out on the outside. So again, this stayed on top. That's why that's here. This moved to the bottom. That's why that's here. The 4 is still the 4. Now that I have all this taken care of, now I can go ahead and start distributing, not distributing that 4. That 4 is going to go to the top one. That 4 is going to go to the bottom one. Notice my numbers aren't getting that big. And it makes it a little bit easier. It's not as clunky as it looked like before. So I have a power to a power. That rule means you need to multiply exponents. So 4 times 4, that's going to give me a y to the 16th on the top. And then 6 times 4, that's going to give me an x to the 24th on the bottom. And if you take a look, I get the exact same answer as I got before. Okay, so technically there's many different ways that you can attack this problem. It just, as long as you're taking legal steps, right? You're not making up your own rules. As long as you're taking legal steps, they should still work out the same way. There's not just one way of doing a problem. All right. All right, let's go ahead and take a look at this last one. Now, this last one's a little bit trickier because that trick that I said, like, oh, let's go ahead and tackle, like, do these two right away, we can't. And the big difference here is everything in here was inside the parentheses. So it's almost like order of operations, right? Like take care of the stuff inside the parentheses first. Well, here, this is inside the parentheses, but this is not. So we can't join these up yet. I need to do it in order. So in this case, you are going to have to do this exponent first. Everything inside the parentheses is going to get that negative 2. That means the 2 is going to get the negative 2. The m squared is going to get the negative 2. And the n cubed is also going to get that negative 2. So let me write this as 2 to the negative 2. Now, I have an m to the 2 to the negative 2. Remember, when you have a power to a power, we multiply. So 2 times negative 2 is going to give me m to the negative 4. And then I have another power to a power, so 3 to the negative 2. 3 times negative 2, that gives me negative 6, so n to the negative 6. Now when I did that, I don't have the parentheses anymore, and I can go ahead and just tackle these. 2n, oops, that's an n, m cubed. Remember, we're going to go ahead and join up like terms, so I'm going to go ahead and join up these guys. This has an exponent of 1, this has an exponent of 1, and that has an exponent of 3. So when I subtract these two, this is going to be negative 2 minus 1. 2 to the negative 2 minus 1. As far as the n's are concerned, I'm going to take, let me do it in alpha. I'm going to take this m, and I'm going to go ahead and subtract the 3. So it's going to be m to the negative 4 minus 3. And then when I do my n's, it's going to be n to the negative 6 minus 1. Because again, this has an exponent of 1, and this has an exponent of 1. All right, and remember, we're going to push everything to the top. That's why the fraction is pretty much gone as soon as we did that. What do I end up with? I end up with a 2 to the negative 3. Negative 4 minus 3, that's an m to the negative 7. And then negative 6 minus 1, that's an n to the negative 7. Look at all those negative exponents. I don't like negative exponents, so I'm going to push everything to the bottom. This is going to go to the bottom. This is going to go to the bottom. And this is going to go to the bottom. Well, if everything's on the bottom, then what's up top? Remember, we can't just leave a fraction alone like that. So I'm going to put a 1 on the top to kind of hold its place, and everything else is going to get pushed down. So that 2 to the negative 3 becomes 2 to the positive 3. That m to the negative 7 becomes an m to the positive 7. And that n to the negative 7 becomes an n to the positive 7. We are almost done, but like as I said before, if you have a number and it's an easy exponent, you should really handle that. 2 times 2 times 2 is not 6. 2 times 2 is 4 times 2 is 8. So on the top, I get a 1 over 8 m to the 7th, n to the 7th, and we are done with that problem. Now, I said that we are pretty much done, except we're going to go ahead and do like a little bonus question. This little bonus question right here always drives my students crazy, or they just look at it, they smile, and they go, "Thank you, Mr. Lechuga, I appreciate that." that you put that problem on the exam. Let's show you what I'm talking about, man. We're going to make this tough. Check this out. X to the 4th, y to the 7th, z to the 12th, over x, y to the 13th, z to the 12th, all to the 0 power. Whoo, here we go. So what do I do? What do I do? What do I do? Well, this is what I do. I say, man, that's a lot of stuff in here. That's a bunch. That's this big red blob to the 0 power. And I know anything to the 0 power? The answer is 1. And we're done. All right, guys. So yeah, that actually is just 1. The answer is done. Like, you can go ahead and distribute this, and you can simplify all you want. But again, you have all of this raised to the 0 power. Anything to the 0 power is 1. You're done. So if you can recognize it, great. Go for it. Just write the 1 and you're done. Okay. All right, guys. That's all I have for today. If you have any other questions, feel free to ask.